And hopefully a quick video. Just going over a quick experiment done by Professor Lewin, and I'll show two versions of this experiment, essentially the same experiment, just accidentally done two different ways. And I would argue that this sort of shows the paradox and the mess, and it's a little bit too sloppy, whatever you want to say. So there is you can notice a little bit of clay on the smaller cart, which indicates to me that they fudged the weight of the car, and that's why this experiment produced the results it did. So anyway, we just play it.
You ready? Yeah.
So you have a one-mass cart hitting a two-mass cart, and what's going to happen, okay, is the two-mass cart's going to leave with 2/3 of the original velocity, which is an increase in momentum. So we're going to make more momentum in a direction, and then the little cart will leave with the reverse direction. So this is the test of the vector versus scalar gibberish, in my opinion. But anyway.
There we go.
Okay, so it does, in analyzing it, it does appear that this cart is, the heavier cart is moving faster than would indicate the one mass object could possibly produce. And it does go in these other directions. So, I'll do a little bit of blackboard stuff just to confirm what we're seeing here. So the one cart goes in with one mass and one velocity. Two mass with 2/3 of the velocity leaves. So instead of 1/2, which would be the same momentum, it leaves with more momentum. So we have a cart comes in, it leaves with more momentum, and we have momentum going the opposite direction. So I'll go get the other clip and be back. Alright, so this is from exactly the same physics lecture, okay, just 20 minutes, 30 minutes later.
This is once the mass. I will.
The anesthesiologist was like, looks like residency did a number on you.
I will set them again to 0. And
all right, twice as heavy cart, half as massive cart, plowing into each other. This time it's supposed to be an inelastic collision, and they're supposed to stick to each other, and they don't.
Now we get one onto double the mass. We ready? There we go. Oh.
All right, so you see the speed here. Now, in the other version of the experiment, okay, it was much faster than half the velocity. So the second cart left much faster, and in this one you can see 275 is much slower. It should have been 222 to be half the velocity. It's obviously much larger than that. 30% larger, so it's like 1/3 the velocity. So it left, instead of 2/3, it left with 1/3 the velocity, and instead of going the other way, the small cart continued moving in the same direction, but at less than 1/3 the velocity. Alright, so if you add it up, it's not a disaster momentum wise, because you have less velocity, much less than half in the two cart, so it obviously didn't absorb all the energy. It lost some, it's missing some, and the little cart is the missing energy. So it all adds up momentum wise. No momentum catastrophe. It's technically the same mathematical equation. You would say that that was an elastic collision, and the other collision was also an elastic collision. So it really isn't a dispute about what the definition of elastic is. Alright, so we'll get rid of that, and we'll add this. And I'll just do a quick rundown on the physics of the experiment. I do have to move that, don't I? it's always something. That should be the right one. Okay, so now you can see that pretty well. Alright, so let's have the mouse. Okay, so you have 100 going in terms of, if I've made the mass 10 and I make the velocity 10, just for the sake of a round number, then it would have a 100 as its momentum, and that's going in. Alright, so in the first experiment, it's basically hitting a 20 mass and 2/3 the velocity. That would indicate 138 of momentum. So your momentum, 133. So your momentum increases by 33, okay, in this direction. And then you have 33 going this way in this direction, because you have 1/3 of the velocity in the same 10 mass object. Now if I do the kinetic energy, it'll come out, you know, with their own numbers. But the clear to momentum, which you can clearly state, is you had 100 momentums in, you have a 165 out. You have 30 extra this way and 30 extra that way. You're saying theoretically they cancel out in some way. I say theoretically the universe says there's 165. You made energy. And I could just repeat this same experiment. I could just have the 20 mass object hit a 40 mass object and increase it again. And then hit a 60 mass object and just keep increasing the amount of increase I'm getting in my momentum. So I would have free energy. Now the catch is this experiment has been done by some other people. The best one I thought was the company that makes the air track. What the hell are they called? I don't remember. Anyway, I could show you that clip, but unfortunately that clip isn't clinically correct because they don't overtly say it's a single mass versus a two mass. You have to imply that's what it is. So without that information, you can't be sure. So anyway, so in this last experiment, the results were completely different. All right. So instead of this happening, we got 1/3, right? And so this number goes down to 70. And then you have 30 over here and 70 over here, and then you have 100. So it works out just fine. So in the one version of the experiment, elastic, the numbers add up. In the other version with springs, the numbers don't add up at all. I mean, you know, isn't that paradoxical? I mean, isn't that a problem? Isn't that inconsistency worth noting?